Okay, we are currently working on the reaction types guided introduction. This is going to help us learn about different reaction types. And I'm going to go through this pretty quickly so you can just get the types. The first, and this probably won't be due. The idea here is for you just to know the types. That's all, that's the only objective. We will answer some of the questions though, but it won't be totally due. Okay, the first type is composition or synthesis reaction. And that's when we have two things combining to form one thing. That's really the main thing. I'm going to just let that sink in for a second. Synthesis means when you bring two things together. Syn, S-Y-N, the root syn, S-Y-N, means together. Composition, basically, when you compose something, you bring things together. So synthesis, and really we'll use the word synthesis reaction. A synthesis reaction is when two things combine to form one. So look at it. It's always just two things combining to form one thing. For the stick figure area, I'm going to just draw. Now this is pretty classic, a classic analogy. It's maybe a little dated, but I'm going to still use it in this case. It's like a guy plus a girl, they make a couple. Oops. So we're going to draw that as stick figures. Why do I say this is dated? Well, why does it have to be a guy and a girl? Why not two guys? Why not two girls? 70 years ago, if you were to suggest that in class, people would be like, what are you talking about? Get out of here. But now these days, it's not crazy. It's not so unimaginable. That's why this is a little bit of a dated analogy, but I'm still going to use it. Guy plus a girl forms a couple. And that's a synthesis reaction. Type 2 is decomposition. Decomposition, like the word decompose, is when something breaks apart. When you die, your body will go into the ground. It will return to the earth. It will decompose. Just like mushrooms decompose things, fungi. It's when something breaks apart. It's when you have one thing and it breaks up into two different things. And here, for the stick figure, it's like I have a couple, the guy and the girl, and they break up. They break up. Heartbreaking. They had a good run. They were dating for about a week. They had a good run. They were dating for about a week. They went on 2 dates, but it didn't work out. They thought it was a lifelong thing, but no, it only lasted a week. Okay. Single replacement reaction. Now this one, we had to take a look pretty carefully. Let's look at this first one. You have Mg plus FeNO32, and look at how Mg bumps out Fe. So Mg is now with NO32 and you have Fe. It's when one thing bumps out another. That's why it's called single replacement. A single thing gets replaced. Or down at the bottom here, Zn replaces H and H gets bumped out. And although this is H2, it's not just H, this is still considered a single replacement reaction. Or take a look here. Look at how you have Cl2 and it bumps out I. So you have NaCl and I2. Again, this is I2, not I, but it's still one thing bumping out another. If I were to draw a stick figure, it's like there is a couple and there is some macho man. Okay, I'm just going to draw a six-pack. He's got a six-pack. All of a sudden, because this guy has a six-pack, We're not good enough anymore. We get bumped out. So this guy is left on his own, and Macho Man is with the girl. Macho Man. Now I'm going to say, there's a lot of things that we have to offer that Macho Man can't offer. Anyways, the guy gets bumped out. It's a single replacement, okay? Let's take a look at question 4. When the single element in the equation is a metal, does it replace a cation or anion? Well, let's take a look. Let's take a look at this last one. This guy is the single and it's a metal. It's going to replace the cation. So H here is positive, NO3 is negative. It replaces the cation. Or for example, in this equation right here, the single is a non-metal. And what it does is it replaces I, which is negative, sodium's positive, it replaces the anion. So you just have to see that what's getting replaced makes sense depending on whether or not it's positive or negative. Here, Cl is a non-metal, it's going to form an anion, so it bumps out the anion. Okay, and I think we did the stick figures already. Actually, let's do one more. This is a simple cartoon that represents, oh, this is a typo. This is a typo. This right here is a typo. This right here is good enough. This shouldn't be here. I'll have to edit that later. Okay, the last type of reaction is double replacement. Did you have a question?
Yeah.
Number 4, metal replaces cation because metals form cations. And this guy, number 7, is a typo. Should be removed. Let's take a look at the last type of reaction, double replacement reactions. If you see here, let's take a look at the top one, AgNO3 and NaCl. 2 of these things are going to switch places. In this case, it will be both metals. So Ag switches places with Na. So you have NaNO3 and AgCl. Same thing here. Fe is going to switch places with Na. So you have, they switch places. So you're going to have Fe with OH and Na with Cl. In the demo that I've been showing you during this class, this is a double replacement reaction. Look at how Pb switches places with K, and K switches places with Pb. So K is now with NO3, and Pb is now with I. What I showed you is a double replacement reaction. This is a double replacement reaction. And if I were to draw a stick figure representation, that would be, let's say you have a guy, and let's say you have 2 couples basically. And how am I going to distinguish this couple? Well, this guy has hair. Let's do that. And this girl has a middle part. Middle part I know has been big for your generation. Middle part right here. And so what's going to happen? It's like they're at a dance and they switch partners. You ever see the dance do-si-do? It's like, grab your partner and do-si-do, something, something, round she goes. And then you switch partners. You change partners. That's the same thing that's happening here. So the guy without hair, the bald guy, is now going to go with the girl with the middle part. And the guy with hair is now going to go with the girl, the ponytail. That's double replacement reaction. Finally, let me show you, let's go over combustion reaction. One of the most famous important types of reactions that we have. Combustion reaction is any time we are burning something. Anytime we are burning something, it is a combustion reaction. And it always has what's known as a hydrocarbon. Anything with carbon and hydrogen is a hydrocarbon. This is one word, by the way. I just don't have enough room. It's a hydrocarbon. You could also say it's some sort of fuel. All life on Earth are made of hydrocarbons. Oil is made of hydrocarbons. Gasoline is made of hydrocarbons. Anything with carbon and hydrogen. And another word to describe this is just fuel, some sort of fuel. And when we burn something, it combines with oxygen to make carbon dioxide and water. That's any time we're burning something. So when you burn wood, what it's turning into is carbon dioxide and water, which are both colorless. But the reason why we have smoke is when something isn't fully combusted. When it doesn't burn all the way and it's only partially combusted, it turns into smoke. Otherwise, if it's fully burned, it should turn fully into carbon dioxide and water. And last thing I'll say is when we eat food, this is the same thing that happens when we eat food. We eat it, we breathe in oxygen, and we breathe out carbon dioxide and water. That's why your breath has water in it. Cars, like regular gasoline cars, sometimes when you drive, yes, when we burn gasoline in cars, it produces carbon dioxide and water. Sometimes you see out of the tailpipe water coming out. When you drive behind cars, you might notice like water dripping out of the tailpipe. It's because both carbon dioxide and water are produced. And those are the 5 types of reactions.